So let's look at another induction proof, but now we're going to look at one involving a factorial. Prove for every positive integer n, 1 times 3 times 5 all the way up through 2n minus 1 equals 2n factorial over 2 to the n times n factorial. All right, so we're going to start with our outline. And we're going to start with our basis step. The smallest n could be is 1. So we're going to start with n equals 1. If I look at n equals 1, then on the left-hand side all I have is 1. On the right-hand side I get 2 factorial over 2 to the first or times 1 factorial. This equation is true. So our basis step is done. Now we're going to move on to our inductive step. We have 1 times 3 times 5. We're going to assume all the way up through 2k minus 1 equals 2k factorial over 2 to the k times k factorial. This is for some positive integer, or you can say integer k greater than or equal to 1. And then what do I need in the end? I need to show that this formula is true up here for k plus 1. So we're going to give ourselves some space. And we're going to write the end of this proof, the end. In the end, I need to show 1 times 3 up through 2k plus 1 minus 1 equals 2 times k plus 1 all factorial over 2 to the k plus 1 times k plus 1 factorial. So here in the numerator, if I simplify the numerator, you're getting 2k plus 2 factorial over 2 to the k plus 1 times k plus 1 factorial. So here we need to show that these two things are equal. And usually we start with this left-hand side, but I'm going to start with this right-hand side instead. So in the end, I'm going to start with, what do we have on the right? We had 2k plus 2, 2k plus 2 factorial over 2 to the k plus 1 times k plus 1 factorial. So if I'm trying to use this formula that I know here. So in particular, my power on k is too large, so I'm going to take 1 away. And the same thing for this factorial. I'm going to rewrite it as, this is the same thing as k plus 1 times k factorial. So I'm going to split those up into k plus 1 and a k factorial. And then in the numerator, I'm going to write this. This is the same thing as 2k plus 2, 2k plus 1, and then 2k factorial. So now, if I factor out 2 out of this first term here, I'll get 2 times k plus 1 I'll get that the 2 and the k plus 1 cancel. So in the end, I'm left with 2k plus 1. And then use our formula for this one. This is the product of the numbers 1, 3, 5, all the way up through 2k minus 1. So now if I rewrite these in the right order, they're all being multiplied, so I can rearrange them. And so this is what I needed to show, because in the end, this last term here, this is really a 2k plus 1, if I simplify it. So we've completed the proof now. Now all we need to do is write this up formally. So let's go ahead and do that. So I'll say proof. We proceed by induction for n equals 1. 1 is equal to 2 factorial over 2 times 1 factorial. Now, comma, assume that 1 times 3 times 5 all the way up through 2k minus 1 equals 2k factorial 2 to the k times k factorial for some integer k greater than or equal to 0. Now we took 2k plus 2 factorial over 2 to the k plus 1 times k plus 1 factorial. If I write the fractions in the opposite order, then I don't have to rearrange when I'm done. So I'm going to write, well, I'll just leave it the way it was. So it's 2k plus 2, 2k plus 1 times 2k factorial. In the denominator, I can split this 2k to the 2 to the k plus 1 as 2 to the k, and split up k plus 1 factorial as k plus 1 times k factorial. So then what did we do here? We pulled out a 2. Which then allowed me to cancel. So this is equal to 2k plus 1 over times this. And we can use our formula from earlier for the second part. This is 1 times 3 times all the way up to 2k minus 1. So if I rearrange the terms, we said that this is 1 times 3, 2k minus 1, 2k plus 1. Therefore, 1 times 3 all the way up to 2k plus 1 minus 1 equals 2k plus 1 factorial over 2 to the k plus 1 times k plus 1 factorial. And that completes our proof.